Hello everyone. Let's continue the activities of chapter carbon and its compound that are given in your NCERT book. The activity 4.7 says that compare the pH of dilute acetic acid and dilute hydrochloric acid using both litmus paper and universal indicator. So you have to check the test on both litmus paper and universal indicator. Are both acids indicated by the litmus test? Okay. So what they are saying is, you are given two acids. One is the acetic acid. Acetic acid is nothing but the ethanoic acid. And the second one you have taken is the hydrochloric acid, HCl, and both are dilute in nature. When you do the litmus test for both of them, what you will get, because these are acids. So, your blue litmus paper will turn into red litmus paper. Same case will be for the hydrochloric acid. Blue will turn into red. And this shows that both are acids. Okay. So this was with the litmus paper test, litmus test. Now let's move on to the universal indicator. Now what is universal indicator? Universal indicator looks like this. It has the range from 0 to 14. And any solution showing the value, the pH value of 7, that is if you dip the universal indicator paper in a solution, if the color comes green, that means the pH is 7. That shows it is a neutral solution. The solution is neither acidic nor basic. If the pH of any solution is more than 7, that means the solution is alkaline. And if the pH value is less than 7, that means the solution is acidic in behavior. Less the value of pH, the more stronger is the acid. Okay? So, this yellow strips, what you see here are the universal indicators. You will take this strip and you will dip into the solution and it will give you some color. And that color you will just check from this indicator, and that will give you the pH value. So let's check with the ethanoic acid first. When you will use the indicator, universal indicator for ethanoic acid, the color of the indicator will be lighter or darker in shade of yellow. And if you check from this indicator, the yellow indicates the pH as 3. Okay. And if you will do this test for hydrochloric acid, the color will be as shown here. See, red. And red pH value, if you check from this, it is 0. pH value is 0. So, in both the cases, you see the pH value is less than 7. That means both are acids. Correct? Okay. But if you will see the pH values, the lesser pH value among the two is of HCl, that is 0. That means HCl is the stronger acid than the ethanoic acid, than the acetic acid. Acetic acid is the common name of ethanoic acid. Correct? So, universal indicator not only tells that whether the solution is acidic or basic in nature, but it also tells that how strong is the acid or how strong is the base. Clear? Fine. Let's move to the activity 4.8. It says that take 1 ml of ethanol, absolute alcohol, and 1 ml of glacial acetic acid along with few drops of concentrated sulfuric acid in the test tube. Okay. See, in this test tube, what you have to take is the ethanol, C2H5OH. And then you have to take the acetic acid, CH3COH. Fine. Then you have to add few drops of concentrated sulfuric acid, that is H2SO4. Then what you have to do is you have to heat this mixture indirectly in a water bath. ठीक है, हम directly heat क्यों नहीं कर सकते? Because ethanol catches fire very easily. तो indirectly heat करेंगे for 5 to 10 minutes. After that, you have to convert this mixture into another beaker which will have approximately 20 to 50 ml of water. So, इस water में you will add this whole mixture which you have just warmed in a test tube. ठीक है? after that, you have to smell the remaining mixture. When you will smell it, you will find it a sweet smelling substance has formed. तो ये जो sweet smelling substance form हुआ है यहाँ पर, that is nothing but ester. So what exactly happened is, let's check with the equation. When ethanol reacted with ethanoic acid in the presence of concentrated sulfuric acid, what we get here is CH3, CO, double bond O, CH2, CH3 plus water. Now this substance so formed is nothing but ester, and this is a sweet smelling substance, and this is used in the making of perfumes, and it is also used as a flavoring agent. जहाँ पर भी आपको fruity flavors चाहिए, there it is used. Clear? Now this concentrated sulfuric acid is here will act as a catalyst, acidic catalyst, and this will not participate in the reaction. Clear? Let's move on to the next activity, that is 4.9. Okay, this activity says that set up the apparatus as shown in chapter 2, activity 2.5. Take the spatula full of sodium carbonate in a test tube. So in this test tube, we will take a spatula of sodium carbonate, Na2CO3, and 2 ml of dilute ethanoic acid. So here we have to take dilute ethanoic acid, CH3COOH. Fine. What do you observe? After some time, we will see that bubbles are there in the test tube. So if bubbles are there, that means that shows that some gas is evolved in the test tube. So pass the gas produced through freshly prepared lime water. What do you observe? Now this gas is then passed into the lime water. Now after some time, when you will pass this, what you will see that lime water turns into milky. So this shows that the gas so evolved in the test tube was carbon dioxide. Okay? And repeat this with the sodium hydrogen carbonate instead of sodium carbonate. Okay, let's see with the chemical equation. What we did here is the ethanoic acid. When ethanoic acid reacted with sodium carbonate, what we get? We got CH3, CONA plus water plus carbon dioxide. Balance the equation. Fine. So here we got carbon dioxide, and how we checked that the gas present is a carbon dioxide? By passing it through a lime water, which turns into milky. Okay. The same experiment we have to do with sodium hydrogen carbonate, and we will get the same product. Na plus water and carbon dioxide will be produced. Okay? Let's move to the next activity, that is 4.10. Take about 10 ml of water in each 2 test tubes. Add a drop of oil to both the test tubes and label them A and B. Fine. We have to take the 2 test tubes. Let's label it as A. And second test tube, let's label it as B. Take 10 ml of water to both, and then add few drops of oil to it, to both the test tubes. What you will find, you know that the oil will be floating on the surface. A layer of oil will be formed over the water because oil does not mixes in the water. तो वो ऊपर एक layer बना देगा. ठीक है? Now to test tube B, add few drops of soap solution. तो इस test tube में हम क्या करेंगे? कुछ थोड़ा सा soap solution डाल देंगे. Then shake both the test tubes vigorously. और क्या देखोगे आप? जैसे ही shake करके हटोगे तो दोनों ही टेस्ट ट्यूब्स में क्या हो जाएगा, जो लेयर बनी थी ना ऑयल की वो नहीं होगी, ऑयल थोड़ा बहुत बीच में पानी के थोड़ा बहुत मिक्स हो जाएगा. देन लीव द टेस्ट ट्यूब्स अनडिस्टर्ब्ड फॉर सम टाइम. और फिर उसके बाद क्या होगा, आफ्टर सम टाइम यू विल सी कि जो ए वाली टेस्ट ट्यूब है उसमें तो लेयर फिर से आ गई है ऑयल की, बट इन द टेस्ट ट्यूब बी देयर इज नो लेयर ऑफ separate layer of oil in the test tube. Now why does this happen? This is because let's try to understand the soap solution ka, as we have already done this कि soap solution is a long carboxylic chains of sodium salts. ठीक है, इस तरह हमने पढ़ा था a soap structure. ठीक है, तो ये वाला जो end है, this end of the soap molecule is the ionic end and this is hydrophilic, means it loves water, it interacts with water. ये जो long chain है कार्बन की, this is hydrophobic. So this does not interact with water, it interacts with oil, it interacts with dirt. तो जब ये ऐसे होता है तो this is how this structure is formed around the dirt, around the oil. This structure. This is how the soap molecules arrange themselves around the dirt, and this structure is known as micelles. So there are lots of micelles formed in the solvent and that forms a colloidal solution. तो colloidal solution में क्या होता है, ऐसे और भी बहुत सारे इस तरह के बहुत सारे क्या बन जाते हैं, micelles बन जाते हैं. तो देखो यहाँ पे एंड पे, एक एंड पे ये एन है और एक और अगर इस तरह का मीसेल दूसरी तरफ बन रहा है तो वो भी आयोनिक एंड बन रहा है. तो बोथ आयंस व्हाट विल हैपन, दे विल रिपेल ईच अदर. वो इंट्रैक्ट नहीं करेंगे, रिपेल करेंगे. बिकॉज ऑफ दिस ये जो सोप सोल्यूशन वाली टेस्ट ट्यूब है वहां पर रिपल्शन हो रही है, इसलिए ऑयल की एक सेपरेट लेयर फॉर्म नहीं होती. एंड दिस इज हाउ ये जो कोलाइडल सोल्यूशन है, ये जो मिसेल्स है, ये रिंस ऑफ हो जाता है डर्ट के साथ जब आप कपड़े धोते हो. फाइन. ओके, लेट्स सी द नेक्स्ट एक्टिविटी, दैट इज 4.11. Take about 10 ml of distilled water. Distilled water means pure water, and 10 ml of hard water in separate test tubes. Okay, so let's take two test tubes, and in one test tube we will take pure water, that is distilled water, and in another test tube we will take hard water, and then add few drops of what, soap solution to both the test tubes. Then shake vigorously both the test tubes. What you will find that in pure water the foam is formed, बहुत सारी झाग हो गई है, whereas in hard water no foam is formed, झाग नहीं हुई है. ऐसा क्यों हुआ है? Instead of झाग वहाँ पे एक कर्डी white color का PPT form हो गया है. This is because we know that the structure of the soap, correct? एक आयनिक एंड है और एक लॉन्ग चेन ऑफ कार्बोक्सिलिक एसिड है. तो जब दिस सोप सॉल्यूशन is mixed with the hard water has lots of magnesium and calcium ion into it. These magnesium and calcium ions will react with sodium and will try to replace it. तो जब ये इसके साथ react करता है तो it will form this curdy PPT, a slippery like slime-like structure that is called scum. And that scum prevents the formation of foam. That means it will not allow the soap to work or interact with water. तो ये जो scum बना है ये इस soap molecule को water के साथ interact करने से prevent करता है. तो वहाँ पे क्या बन जाता है? curdy PPT. Clear? Let's see the next activity, that is 4.12. In this activity, what they say is take two test tubes, and in both the test tubes, you have to take hard water. And then you have in one test tube, let's label it as A, and another test tube, let's label it as B. In both the test tubes, we have hard water. In one test tube, you will add few drops of soap solution, and in B you will add a few drops of detergents. So when you will shake them, you will find that in test tube A, where you have added soap, will have a curdy PPT in it, whereas the test tube B will have foam in it. Foam is form, झाग बन जाएगी in test tube B. अब ऐसा क्यों हुआ है? Now let's try to understand with the soap molecule structure. This is what the soap molecule. Soap molecule, when it reacts with hard water, which have lots of magnesium and calcium ions in it. So when this reacts with the sodium salts of carboxylic acid, that is soap, so it will form scum. That is nothing but this. It look like a curdy PPT in test tube A. ठीक है? Whereas in detergents क्या है? Detergents are the sodium salts of sulfonic acids. ठीक है? तो ये है इसका आयोनिक एंड. किसका? डिटर्जेंट्स का. तो सिर्फ आयोनिक एंड का चेंज हो गया. यहाँ पे सोडियम था जो कि मैग्नीशियम और कैल्शियम हार्ड वाटर के में जो होते हैं आयंस, उसके साथ रिएक्ट करके स्कम बनाता है. दैट प्रिवेंट्स कि द फॉर्मेशन ऑफ फोम इन द हार्ड वाटर. वेयर एज इन डिटर्जेंट्स इट इज द सोडियम सॉल्ट्स ऑफ सल्फोनिक एसिड्स और एल्युमिनियम ऑल्सो. ठीक है? तो जब दिस रिएक्ट्स विद मैग्नीशियम एंड कैल्शियम प्रेजेंट इन द हार्ड वाटर, तो दिस विल नॉट फॉर्म स्कम. नॉट फॉर्म स्कम. इसलिए द डिटर्जेंट्स वर्क्स बेटर इन हार्ड वाटर. तो सोप जो है वो सिर्फ सॉफ्ट वाटर में ही काम करता है, whereas detergent works in both hard water as well as in soap water. With this, we finished the chapter Carbon and its Compound. If you like the video and find it helpful, do like, share and subscribe it. Thank you and bye.